Good morning everyone and welcome to another video on Mr. Ong Math Lesson. Today we are going to look at the 2020 NCEA Level 2 probability method. Sorry for the delay because I was quite busy at school. So since today is the first day of the holidays, I will continue with the second question. If you have not watched the first question in the previous video, please do so. And the third video will be coming out soon. So question 2 is technically normal distribution. So if you do not know normal distribution, please go and learn them because you have to do it either using your graphic calculator or using the table. If you don't have a graphic calculator, you'll be disadvantaged. So for the purpose of this video, I will do the graphic calculator because it's faster and easier. Okay, let's go. We shall read question 2. Range anxiety is the worry that EV drivers have about how long their battery charge will last. This is one of the most common concerns that stops people from buying an EV. So a car manufacturer claims that EV can travel 172 on a full battery charge. So we're going to check that. Jeff, an EV owner, recorded the distance and after that his car traveled after each full battery charge and found can be modeled by a normal distribution with a mean of 165 and a standard deviation of 14. So in a normal distribution question, you have to always draw the graph. So the mean is in the middle, so the mean is 165 and standard deviation represented by sigma, it is 14 because 14 is sigma and mean also called the nu is 165. You want to calculate the probability that it will travel between 150 to 165. So we shall draw the graph and this is the area 150 to 165 is this area. So to do that, we use our graphic calculator. So the first thing we do, you go to menu, go to statistics, and then you go to normal distribution, okay? And then we are going to do that. So the first thing you do, you put the data as variable. The starting point of the area is at 150. So lower is 150. The ending point is at the highest point is 165. So the upper is 165. And you know that the sigma or the standard deviation is 14. And the nu is 165. Put in the calculator and then just press the execute button. And the answer is 0.358. And that will give you an achieve. Not too bad, right? Great. Now we shall do part 2 of question 1a. Part 2 is similar. Another achieve question. Just that put in your calculator and you will get an achieve. So we shall read that, okay? So part 2 looks like that, okay? So we continue that, okay? So find the probability that Jeff EV will travel more than 172 on a one full battery charge. So the mean is again 165. Standard deviation nu is 114. And you are looking at more than 172. So we are looking at this area, the red area. So to do that, we bring our graphic calculator. So exit. So now back to the lower is where you're going to start. So lower is going to be distribution, goes to normal, NCD, and now data is variable. The lower is where it starts, so 172, execute. Upper is going to be a big number, so I'm going to put 10,000, or you can put 1 million if you want, execute. And then the mean is, the standard deviation, sigma is 14, and that's done. And the nu is 165, put in your calculator, and the answer is 0.3085, and that is another achieve. Not too bad, right? Okay, now the next two questions is going to be inverse normal. Please listen up carefully, and then we shall get the next one is the merit, and the last one is going to be an excellent. Okay, so we look at the merit question. Again, we shall go back, go to statistics, exit, go distribution, normal. Okay, so we leave it at this. Okay, so 10% of the time, Jeff is unsatisfied on how far one battery charge will take his EV. For Jeff to be satisfied, what is the minimum distance his car will have to travel for one full battery charge? So 10% is 0.1 or 10%, the red area here. You want to find what is the minimum distance before he is satisfied. So the mean is still the same, 165. and the standard deviation is 14. So now this is an inverse normal. You want to find the x. So what you do, you go to inverse normal, and now you need to calculate. The area is on the left, so we put left there. Okay, so the area is 0.1, so we put 0.1. Execute, 0.1. The area is 0.1, and then we execute, and then the standard deviation is 14. Execute, and the mean is 165. Put in the calculator, and the answer is 147, and that will give you a merit. Not too bad? Great. Now we do the excellence inverse normal. This is slightly different. Okay, when they ask you to calculate the mean or the standard deviation, you have to use this formula. Okay, this is the standardized formula. Z equals to x minus nu over sigma. It means that this is a unstandardized data, and you want to standardize them. Okay, so we read the question now. Okay, so the same car manufacturer released a second generation EV. A new owner found the second generation to be 20% of distance travel on a full battery charge was less than 265. Okay, so 265 is 20% or 0.2. Assume that distance travel, calculate the estimate for the mean. So you want to calculate the mean here. Okay, so you have to be more than 265 on a full charge by a second generation EV. Okay, assume that the distance is modeled by normal distribution standard sigma is 14. So this is a non-standardized. You have to standardize your data. So we replicate it. When you standardize, you just need to change the mean to 0 and standard deviation to 1. So we are going to find the Z value here. Once we found this Z value, we're going to substitute the Z, and using this formula, we are calculating the U here. Okay, so we shall do now. So again, we are going to standardize it. So when standardized, remember the mean is 0, standard deviation is 1. So go to menu, go to the distribution, again normal, inverse normal. Okay, so your tail is again on the left, so you go put left. The area now is 0.2. Execute. The standard deviation is 4. This time you standardize it, so your standard deviation becomes 1. Yes, and the mean becomes 0. Okay, and the mean is going to be 0. Now you're going to execute them and execute, and the answer is 0.48 negative 0.8416. So that there is negative 0.8416. Now you want to change this Z to the new here. Okay, to do that, so the 265 is converted to negative 0.8416. So now you know your Z is negative 0.8416. Your X is the value here, 265 minus nu, that's what you want to find out, and the sigma is 14. Use your algebra calculation and calculate nu, and you should get the answer as 276.8, and that will be an excellent question. And this question will also be taught in the level 3 statistics concept paper. Got it? Good. Now the last part is about answering using, we have take out our graphic calculator now. Okay, so an independent company completed 70 test drive for the second generation EV. Each test started with a flat battery and ended as expected, shown on the graph. So this is the experimental data. Your original data is called a normal distribution. They want you to compare this data and that data. So we named it as experimental data, and this is called the normal distribution. So they ask you compare the shape, center, and spread of the histogram with the normal distribution and provide numerical values as provided. Okay, so I'm going to put the graph here, and we're going to talk as we go along. Okay, so the first one, we can talk about the center. Okay, the center, so the mean from the normal was 280. We found it before. If you calculate the mean using the midpoint and calculate the mean, it's going to be 274. So technically, they are quite close. So we can say that the mean is about the same. So the mean is about the same. So we can compare these two means are about the same. So next one, if you calculate anything that's less than 280, you calculate the frequency. You found out that 47% of them is less than 280. So 53% is more than 280. So the median is into 50%. So it's slightly more than 280. So normal distribution could be valid. So comparing the center, that should be fine. Okay. So the next one is the spread. Okay, the spread. We can talk about the spread now. The spread is, okay, if you compare the spread, the range is from 220 to 320. So it's around 100. To calculate the standard deviation, you just, on rule of the thumb, 100 divided by 4 is about 25. So the distribution for this graph is a lot higher. The standard deviation is a lot higher compared to this. We found that the standard deviation for this was 14. So that's one point we can talk about. Okay, and if you compare the normal distribution plus 3SD, so most data lies within 99% of the data lies within 3SD. So 280, the normal distribution graph, 280 plus 3SD, so 3 plus minus 3 at the SD of 14 is going to be range of 84. But our experimental data, the range was 100. So this experimental data has a higher range than the normal distribution. Okay, so that's point 1, point 2, and the last point, the normal distribution is normally bell-shaped. This is more skewed to the left. If you look at the graph, it's more skewed to the left, and the data is not totally unimodal compared to the normal distribution. And the last point I'm going to say is that data is collected in a city, so it may not apply more to the rural road. So technically, that is the answers for question 2 of the probability method. Hopefully you go through question 1 and now you're done question 2, and have a good day. Cheers, everyone.